We are looking at applications of the ideal gas law. It's today's lesson. Your lungs hold about 4 liters of air. When you breathe out, only 500 milliliters of air is actually expelled, okay, when you're exhaling. Same amount of air is taken in when you inhale one breath. So, if you, one of the new calculations you're going to have to do is actually calculating density. So going back to grade 9, when we calculated density, density was pretty much is a unit, set of units that is, you use your mass and you divide it by whatever the volume is in which the space kind of occupies. Okay, well, we'll talk about that in just a second. We talked about molar volume the last lesson. Molar volume of a gas is defined as the space that is occupied by 1 mole of the gas, and so it's reversed from the molarity. Right, so it's liters per mole. Okay? So what volume of space is being actually occupied by the actual gas? Density of a gas is similar to the density of a solid or a liquid. Right? So as I said, you're pretty much taking your mass and dividing it by your volume. Okay? Common units will be grams per liter for when calculating density. Okay. So, molar mass of a gas refers to the mass, which is usually in grams, of 1 mole of a gas, right? So we've already known, we know that if we've got mass, odds are we need to find the number of moles, right? Sometimes you might be asked to find the mass of something, so you maybe have the moles, use the molar mass to help you find the actual mass itself. So, molar mass always expressed in units of grams per mole. So here we have 3 sets of units. We've got molar volume, density, molar mass. Okay, so notice the units liters per mole for molar volume, grams per liter, grams per mole. Here's the equation, as we said, for density. Density is equal to mass divided by volume. Okay, so just a few things to keep in mind when going through some of the sample problems that we're going to be looking at today. All gases have the approximate volume of 22.4 liters at STP. Right? So if we're looking at at a gas at STP, and you're thinking, well, it hasn't given me volume, but I'm also given another unknown that I need to find. Keep in mind that the hint is STP. That's your volume, so your volume will most likely be 22.4 liters. Molecular masses of different gases, however, are all different, which means that each gas has a different density or mass per unit of volume. So even though all gases may have at STP the same volume, their density is different. Right? Remember, to calculate density, mass over volume, and to find mass, if you knew the number of moles, use the molar mass. Right? Take that number, divide it by your 22.4 liters, right? And all these gases will be different. And we had a chart in the last lesson that pretty much went through 3 just random gases. And the one thing that was different, even though they were all, at the same pressure, same volume, 22.4 liters, the big difference was the density between all these gases. And it's a very important property to know about gases. So let's look at the first sample problem. Nitrogen gas makes up almost 80% of our atmosphere. What is the density of pure nitrogen gas in grams per liter at 12.50 degrees Celsius and 126.63 kilopascals? So what I want you to do is I want you to actually isolate what are your givens. Let's look at some of the givens. We've got a pressure, right? Pressure, 126.63 kilopascals. We've got a temperature, 12.50 degrees Celsius, which we want to change to Kelvin, which is equal to 285.5 Kelvin. So far those are two givens. 80%, well, we know that the atmosphere itself has 80% nitrogen, but it's really not going to play any role in this actual question. Now, we've got things to find. N, right, the number of moles, but we can pretty much find that with some of the information that we've got up here, right? We've got R, the constant, which is 8.314 kilopascals, liters over moles of Kelvin. And we're trying to find the volume. But now, here's the hint. Question asks you to find the density of pure nitrogen gas in grams per liter. Right? This grams per liter. How many liters is it referring to? 1 liter. I'm just going to put a couple extra significant digits in there. Liters. Okay, so we've got the following sets of units. Now, to find N, right, we're referring to nitrogen gas. All right? So what bit of information might we want to find about nitrogen gas? Because we're trying to find the grams per liter, right? Because density is equal to mass over volume. So we're ultimately going to need to find the mass. Right? So if we need to find the mass of nitrogen, right, what bit of information should we have about nitrogen? Molar mass. Okay. So the molar mass of nitrogen, I have it written down here, 28.02 grams per mole. Right? So we're trying to find, really the only unknown is how many moles do we really have? We know a molar mass is that, but we don't know how many moles we actually have of this gas, right, in the atmosphere. So we have the equation PV equals nRT. So what we want to do is isolate for what? N. So we isolate for N, and let me use a different color here. N, right, is equal to PV over RT. So let's substitute our numbers. So pressure, 126.63 kilopascals, multiplied by the volume, which is 1.00 liters, over 8.314 kilopascals, liter per mole, Kelvin. Like I said, try to keep your units going, just to help you with crossing out and knowing which set of units is the last unit standing, so to speak. Right, and we've got our temperature, which is 285.5 Kelvin. So we go in, cross out kilopascals, liters, Kelvin, last unit remaining is mole. So we know that mole will be the units that we're trying to find. So our N value is equal to, when we multiply all that and divide it, we end up getting 0.053348 moles. Right? So we have the number of moles, we have the molar mass. Right? So between the two, right, we're trying to find the actual mass itself. So the mass itself is equal to the number of moles multiplied by the molar mass. Right? So let's substitute our numbers. We've got 0.05338 moles multiplied by our molar mass, which we found earlier on, 28.02 grams per mole. Right, moles cancel out. My units are in grams, and I get 1.4948 grams. Right, so we've got our mass, but now question asks the density. Right, but what was the volume that we're referring to? To 1. Right, so anything divided by 1 is 1. Right, so let's just throw that in here. So we're going to divide this mass by the volume of 1 liter, and we know that the density is going to equal to 1.4948 grams per liter. Least number of significant digits in my question is 3. Right, ignore that. We don't need to worry about that. So it's 1.49. We look at this number here. It doesn't change. Actually, is it 3? No, it's 4. 4 significant digits. Sorry. So 1.494. We look at the 8, and the answer for density equals 1.495 grams per liter. Okay. So, of the atmosphere, at that pressure and at that temperature, the actual pressure exerted by, the actual density of the nitrogen gas in the atmosphere is 1.495 grams per liter.